NumPy arrays, I guess we're most familiar with two-dimensional, right? Spreadsheets, X, Y. NumPy can have as many dimensions as you want. So a handy command when you want to create a NumPy array is this zeros command. What the zeros command does is you tell it the dimensions. It has to be in parentheses. That messes me up often. So in parentheses, each of these items is a dimension and how big, how many elements in each dimension. And it goes in the order Y, X, and then you can keep on going. So this says we have 3 numbers here, so it's 3-dimensional. If I put in after the 3 comma another number, it'll be a 4-dimensional array. So NumPy doesn't care. You can do as many dimensions, but it's a power function, so you're using up a lot of memory if every dimension you add. So for color, we need 3 dimensions. You tell it how many elements in the Y, how many elements in the X, and then how many channels. If you wanted to do a grayscale, you would just do YRes and XRes. That would just be 2 channels. You wouldn't need the 3rd channel. So what this is doing is it's creating an array all filled with zeros, so it'll look black. And you have to tell it what type of numbers are in the array. For images, as we mentioned, we're using 0 to 255 integers. So we're specifying a NumPy array that's 3 dimensions with a data type uint8. That means unsigned integers, 8 bits. That means it's 0 to 255. Okay, I don't know if you know about bits and bytes, but 8 bits, zeros and ones make a byte. The largest value you can have is 255 in an unsigned byte. Okay, so just this one command will create an array that OpenCV, when you use that imshow command, it'll display this. And even if you fill this number up with like a sine wave table or just random numbers, it'll treat it like an quote image. It'll show you, it'll combine all the RGBs to make a color image. So if you want to play around with math and make functions and then look at the data, it'll think it's an image if you create it in this format. So here's some useful NumPy functions with images. I mentioned shape. That's really handy for figuring out what resolution an image is. Because when you do your shape, remember back here, we did shape and we could tell, oh, in the Y it has 480, in the X it has 640, and it has 3 color channels. Dimensions, is very similar to shape. It'll just tell you the number 3, that it has 3 dimensions. D-type is important. Sometimes if you do a calculation and it's floating point and you try and display it, it'll show an error. So the first thing you can do is ask what type it is. It has to be an unsigned int of 8 bits. And then length, len, I assume you've used that instruction before. It basically tells you how long an array is or a list is. And we did that last week when we wanted to see how many objects we had. I highly recommend image processing with Python, datacarpentry.org. I pulled these pictures out of that website. It has a lot of good information on image processing. So if you want to hear a second view of what I'm presenting here, go to this website, and there's a great tutorial and there's instructions, little snippets of code you can run, which is the best way to learn this. So this is in the slide deck. So I highly recommend you look at this this week. And if you have any questions, feel free to email me. Only one student has emailed me, so I have a lot more bandwidth for you students. Okay, so we've established that a NumPy array, if you set it up as an unsigned 8-bit array, can be viewed as an image. If it's 2-dimensional, it'll be viewed as a grayscale image with 0 is black and 255 is white. If it's 3-dimensional, it'll be interpreted as a RGB, or as we now know is BGR, color image, and it'll render it as a color image.